Welcome everyone, my name is Sebastian and this is the pitch video for our SIGMOD demo submission, proactively screening machine learning pipelines with ArgusEyes. So ArgusEyes is a library that we've recently built, which helps data scientists find hard to detect data-related issues in their machine learning pipelines. And in the demo submission, we prepared 3 different machine learning pipelines with 3 different kinds of errors. But in this pitch video, I would like to walk you through only one of them as an example. So ArgusEyes is built for Python-based machine learning pipelines. The example that we used here is inspired by real-world code from Databricks. And this pipeline is about predicting taxi prices in New York. And it consumes historical data about taxi trips, about the distances for these trips, and about their prices. And we use common, in the code here, the data scientist uses common libraries. We use pandas to read CSV files, Parquet files. We filter the data, we join and integrate the data, we compute some features, we encode features with scikit-learn, and then train some kind of model. So the code prepares this data set, then splits it into a train and test set based on the time of the trips, so that we train on trips from the past and predict from trips in the future. And in the end, we calculate the accuracy. So this is an example of a typical machine learning pipeline that a data scientist would build. We can run the pipeline, the accuracy seems to be pretty nice, and people would put this into production, and then maybe there are some data-related issues and something goes wrong in production, but usually these issues are very, very hard to detect. Now, the idea in ArgusEyes is that we provide a validation library that knows how to check for common errors in machine learning pipelines, and ArgusEyes can automatically screen these pipelines for these errors. So we will show this for you. So ArgusEyes needs a configuration file that points to this Python pipeline, and then it executes the pipeline, instruments its execution so that it can capture some of the data artifacts. And most importantly, it also computes fine-grained provenance for all data artifacts. And based on this provenance, it can run all kinds of checks. So in this case, actually, there was some leakage in our pipeline. So ArgusEyes tells us that there's 177 records that were present in both train and test set. And that means the accuracy that we see for this model is unrealistic, and that's something that we should fix. And ArgusEyes also helps you to actually fix these errors. So ArgusEyes stores the artifacts and metadata about this pipeline in MLflow and an experiment database. And then we provide some specialized debugging tooling that you can use via Jupyter that helps us analyze why there was a particular issue in the pipeline and fix it. So for that, we only need this MLflow ID. And then we can connect to MLflow and look at all kinds of metadata about our pipeline. So for example, we see a query plan of the pipeline, which shows us the data. We can inspect this data. We can also see the training and test feature matrices that were built internally. And then we have specialized so-called retrospectives that help us understand a particular error type. So for data leakage, we have a data leakage retrospective, and we can ask this retrospective to show us actually the actual tuples that were leaked from the train set to the test set. So that's what you see here. And then the data scientists can explore these tuples to try to figure out what the reason might have been for the leakage. And we see some exploratory code here. And actually what the data scientist would find is that all the leaked tuples have the same drop-off date time. And that could give them a hint that actually the split into train and test set was done carelessly, because basically the one day that is between the train and the test set was in both of the sets. So we would have to change the comparison operator to a greater here for these dates. If we would fix this, rerun the pipeline, this data leakage issue would go away. Under the covers, ArgusEyes actually, as I already said, computes the provenance polynomials for all the inputs. We hide this for convenience, but it's also accessible. So Data scientists can also access the provenance polynomials, both for the train and test matrices and for the inputs, and that's what ArgusEyes uses to run all kinds of checks. And for the demo, we have 2 more cases. We also show how to detect fairness violations and label errors. And we also provide a repository of ArgusEyes that shows how to configure ArgusEyes to run certain kinds of checks. This is very easy, just needs some YAML configuration. And we also show how to actually integrate it into GitHub so that these ArgusEyes checks are run as part of the build on GitHub, and then the build would fail and data scientists would be notified if there would be some kind of issue. So ArgusEyes can serve as some kind of continuous integration system for machine learning pipelines. That's all. We hope you like the pipeline, and have a look at the repository if you want to learn more.